Welcome back to the Automation Podcast. My name is Shawn, and this week on the show, we're going to take a look at the evolution of the programmable controller. We'll start by taking a look at some of the earliest models to come out. Then we'll look at the development over the years. We'll take a look at what a PLC is and compare that to what a PIC is. And then we'll take a look at what the current major vendors are doing with their product lines. And we'll even take a look at what the future might hold for this product. Now, those of us who grew up in the 70s and 80s got to witness the launch of so many new technologies, like the ability to record live TV or watch movies at home on our TV with the invention of the VCR. We also were able to bring video games home from the arcade and play them at home on our television using video game consoles. And we even were able to get studio quality sound from our stereos with the invention of CDs. So much better than tape decks. Now, that said, with all those products coming out, there was one product that really got my interest back in the day, and it was the new affordable home computer. Previous to that, computers were very expensive and out of the reach of most people. But in the late 70s and early 80s, there was a bunch of companies releasing new affordable home computers. And at school, we learned on the Apple II. A lot of you iPhone people don't even know what that is, right? And at home, I actually purchased myself a Commodore VIC-20. And I went all in. I spent my preteen years programming and learning the program. And I bought a modem for it. And, I was calling all kinds of places after seeing the movie War Games. And I even have a CompuServe and Prodigy online accounts. And this was a time that was years before the invention of the TCP IP-based internet in 1983. And it was a decade before you would actually be able to get your own internet access account through a public ISP. That came in 1989 here in the US. And of course, it was over a decade before the first web browser was even invented. Now, all that said, those trying to actually automate their plant floors back in the 50s and 60s, they didn't have personal computers. They didn't have the internet. As a matter of fact, Unix wouldn't even be invented until 1969. Intel wouldn't release the first microprocessor, or CPU, until 1971. And the programming language C, that didn't come out until 1972. So you can imagine the challenge it was to try to automate back in the 50s and 60s. It was daunting, right? And most of those efforts would fall into one of two categories, either a mainframe computer style control or an electronic system style of control. And while this development was going on around the world, one story in North America really has captured people's imaginations. And that story starts back in 1968. Now, the good engineers over at GM, they had recently purchased an IBM 1801 computer. And these things were expensive. They started out at like $500,000, right? And they weren't satisfied. They weren't satisfied with the support they were getting and the performance they were getting. And so they developed what they called a standard machine controller specification. Now, there were multiple groups inside of GM trying to automate their systems, but they actually developed and released this 4-page RFP and sent it out to all the major vendors. Allen Bradley got a copy, Cutler Hammock got a copy, and so on. Now, it took a year for anybody to actually submit a product to be evaluated as a standard machine controller. And the first product received in June of 1969 was from Digital Equipment Corporation, or DEC, and they provided a PDP-14. Now, the PDP-14, a lot of people consider it a mini computer. It's not small. It's not like a micro. It's still very large, very expensive, $250,000 or more. But at the time, it was a lot less expensive than like an IBM computer. And they wanted to evaluate it to see if it could be used as a standard machine controller. But it had one Achilles heel. At the time, it was such a new product that DEC wouldn't allow the end user to actually change the program. They would actually have to pull the memory card out, send it back to Massachusetts to DEC. DEC would have to change the program and then send it back to Michigan for the GM people to install. And that was a major stumbling block for DEC in this evaluation. Now, the next company to submit a product to be evaluated was a company by the name of Information Instruments Incorporated, or 3I for short. And this company was working with the computer group at GM, looking at automating their assembly machines for the clutch line. And as the story goes, the computer group wanted something that programmed similar to other things they had in the plant, right? Which were programmed like a computer using mnemonics. And again, remember, this is before C++ or even C, the programming language C was invented. So we're talking assembly languages here, right? So in any case, that was one of the goals. There was another goal that had to do higher level functions than what some of the simpler devices would do. And it had to be fast because these were assembly machines. Faster they go, the more parts you can assemble, right? So in any case, in late summer, 3i presented their product, the PDQ-2, to be installed on the assembly line for the clutches in the computer divisions group. And then the last product to get submitted in the fall of '69 was from a company known as Bedford Associates, and they provided a product called the Modicon 084, purpose designed for this evaluation. And you may be familiar with that name. There's a lot of stories about that name and how it came to be. I'll leave that for, if you're interested in that, you can research that more. But in any case, this was provided to the people in the circuitry group, not to be confused with the computer group. In the circuitry group, they needed something to replace their big relay panels, very complicated, very large relay panels. That's what controlled all of their sequences of their machines. And so they were looking for something that would reduce the size of what they had and would make it easier to make changes, right? So in their case, having to rewire a bunch of relays, that's not time efficient, right? But changing a program, that should be very quick. So that was what their purpose was. And because they had so many relay panels and their staff was trained up on relay ladder diagrams, they were encouraging Bedford Associates to produce something that would be similar or easy for their people to understand. And so what they did with the Modicon 084, Bedford Associates created a system where you would program not with mnemonics like XICOTE, but with actual little contact symbols and coil symbols. Now, there were some limitations on this early unit. You could only have 4 contacts per rung, but it was intuitive and easy to use for the people in the circuitry group. And so they really gravitated toward it and really liked it. While the computer division, who were doing the assembly machines on the clutch line, they really liked the PDQ-2 because it was fast. They actually nicknamed it pretty dang quick. It allowed them to do advanced functions, more advanced functions than the Modicon did. And it programmed the mnemonics, so they could type in XIC, XIO, OTE, and that was their program. So if you weren't a mnemonic programmer, if you weren't used to doing assembly language and those type of low-level languages, well, then you would have to go through a conversion process to convert your ladder logic into these mnemonics. And you know what? That's not for everybody, right? So after a year of running all these devices through their paces, they came up with a summary document of what they found. And as you can imagine, the PDP-14 from DEC didn't make the cut because they still weren't allowing them to edit the programs there in the plant. And so that was a major downfall. The other thing that we can take away from this summary is that, different products are made for different people, right? So the computer division, they needed advanced features, they needed high speed, and they wanted something that programmed the mnemonics, right? So they got the PDQ-2, which they really loved. The circuitry group, on the other hand, they were replacing large relay panels. They wanted to put something in there that was kind of like similar to, relay ladder diagrams. And so even with its limitations, they really liked the Modicon 084. And so what came of this early test and review of programmable controller products? Well, as the story goes, Bedford Associates ended up mass producing the Modicon 084. They created a whole new company called Modicon, which would eventually be owned by Schneider Electric today, who still makes Modicon PLCs. And as far as 3i, well, they saw in the summer of '69, they saw how big a market this could be. So they approached Allen Bradley about investing in their company so that they could develop new products. And Allen Bradley did. They bought 25% of the company, and they also got exclusive rights to sell and market the PDQ-2. And you'll see the very early brochures for the PDQ-2 have both the Allen Bradley logo and the 3i logo on it. Now, that said, by 1971, Allen Bradley was convinced this was going to be a great market, and they ended up buying the rest of 3i. So they owned the company completely. Now, as I said, development was going on around the world. It wasn't just at this one little GM plant in Michigan, right? And by the early 1970s, there were over a dozen vendors actually manufacturing and selling programmable controllers. And in the early days, there was a lot of innovation, a lot of people jumping into the business. And by the 1980s, we started to see some major shifts. First one was networking, right? Putting multiple PLCs on a network or having a PLC talk to its remote or distributed I/O over a network, right? With the introduction of Modbus and Data Highway Plus in 1979, we saw a quick adoption of networking. And a lot of plants, especially large plants, would install networks of PLCs and have them talk to each other. Another major milestone in the early 80s was the release of the IBM personal computer. Now, personal computer adoption in business had been kind of slow up until that point. But with the release of the IBM PC, based on an open standard, not only did it give credence to the value of a personal computer, but also it allowed anybody to build an IBM-compatible PC clone like Compact or Dell or Gateway. And so with a new standard in place, the software and the hardware just exploded. And this is where we start seeing software being developed for PLCs. So you didn't have to lug around a very heavy, programmer that had been the standard for programming PLCs. Now you could use a standard IBM PC to program, well, if you had the right software, program any PLC, right? And so that was great. And in 1985-86, Allen Bradley actually released their first programmable controller that only used a PC for programming, and that was the PLC-5. Now, another thing that happened with programmable controllers in the 1980s is that they left the old flat memory table like 0000 through 4000, and they adopted data blocks or data tables. These were memory spaces that the user could create. So let's say you had a PLC-5 and you wanted a new timer file. Well, just create one in file 10, call it T10. And then the elements of that, you don't have to remember the actual bits and bytes. If you wanted to know what the accumulate value was, it was T10:0.ACC. You wanted to know what the timer timing bit was? That was .TT. So it really made programming these PLCs much easier by not having to remember, is it 200, is it 200.13 or .12, which is the done bit, and so on. So that was another major development in the 80s that made it easier and made programmable controllers more accessible to the average user. Now we go from there and we look in the 1990s, and really the evolution of the programmable controller in the 1990s, I think, were affected by a couple of big factors. Number one, the release of HMI. So we have in the early 80s the release of the IBM compatible PC. And then in the early 90s, we had an explosion of inexpensive HMIs come on the market, whether it was LCD displays or CRT displays, with touchscreens or keypads. There was just a little explosion. I still remember when the PanelView 550 came out, and it was so inexpensive compared to the previous models with its monochrome display, and it was a big hit with OEMs because it was finally, you had an operator interface that cost less than putting a dozen buttons and lights on a panel. And the software was a little clunky at first, but it grew on people over time, and HMIs just really exploded. Today we almost never see a panel full of buttons and lights. They're all replaced with either an HMI or a SCADA package. Another thing that happened in the 90s was the explosion of Windows, right? So with DOS, you could typically only run one program at a time. So if you were programming in your PLC software, let's say you're using 6200 or AI series, and then you're like, oh, I got to go find out what I did in the HMI software. Assuming you only had one computer, you would have to save and close your PLC software and then open up your panel builder or HMI software and then go do whatever you needed to do there. And then if you're like, oh, I can't remember what I did in the PLC software, you'd have to close the HMI software and open the PLC software. And you can see where I'm going with this. Painful, right? Very, very painful. And then there was always battles with memory and extended memory and all that. So, and of course, then there was also printers. Not all software supported all printers because there was no unified DOS printer driver that would handle all printers. So with the release of Windows, right, it really gave the PC users of the time the ability to run multiple programs, and maybe you have a corporate email that you needed to check and access, or, maybe you had some PDFs were coming out and becoming popular to replace, hardcover books. And so it gave you the opportunity to have multiple programs up at the same time. And if you look at Windows 95, that came out in 1995, you'll see the explosion of the adoption of Windows just goes off the roof. And actually, the adoption of personal computers, too, just skyrockets after the release of Windows 95 because it was so intuitive and so easy to use. And so those two developments really affected PLC development in a big way. And the fact that there was so many more computers and HMIs talking to PLCs over the legacy networks that were developed in the late 70s, early 80s, I mean, everybody could see that there was a bandwidth issue, right? We just didn't have enough throughput on these old networks for all these new devices, right? Especially HMIs are notorious for creating, sending a bus to pick up a single person, right? So sending an entire packet to pick up a single integer value, right? So in the late 90s, we also saw an explosion of new networks, of next generation networks based on Ethernet, networks based on CAN, and even a network that's really not based on anything, ControlNet. And one of the things Rockwell did is they designed all three of their NetLinks networks, DeviceNet, ControlNet, and Ethernet, to be around a common industrial protocol, an open protocol, which was a first for Rockwell because they had always had, that intellectual property around Data Highway Plus and Remote I/O. So with that said, that was really what I saw the evolution in the 90s of, and then we get to the late 90s, very, very late 90s, early 2000s. And from my perspective, the biggest thing that happened there was the release of the ControlLogix. Now, this was a system designed to be the next generation controller from Rockwell, right? And this is where they changed the name from PLC to PAC, right? And this was a system with a chassis that you could install the network cards without any controllers, right? You could just have the network cards. These were smart network cards, bridging cards that could actually bridge between each other with no program. So if you put in an Ethernet, ControlNet, DeviceNet, DH Plus Remote I/O, you could actually bridge between all of those. No programming needed. They were automatic because they all were based on CIP. And there was a legacy exclusion in there for PC cubed for the Data Highway Plus. So in any case, those were very cool, right? And then we had the ability to, put in one Ethernet card and then maybe 5 Data Highway Plus cards. Maybe you had 5 Data Highway Plus networks out in the shop, and you could access all your PLCs now from a single PC on Ethernet in your shop or your office shop or your front office. And that was amazing as well. It's just such a great ability not to have to run 5 blue hoses all the way back to your office, right? And from there, we also saw that the controllers were these next generation controllers. They were multidisciplined. They were designed not to just do, digital, but also to do process, also to do motion control. Before that, in the Rockwell world, most of the motion control you would probably do in a separate motion controller, right? But here, they were putting the motion control right into the controller itself. And, if you need a Mono 1 controller, you could put as many as you could fit in a chassis, well, until you ran out of power. But if you needed 10 controllers, you could put 10 controllers. They could go in any slot. So pretty amazing stuff. And of course, on the software side, it was, supported 4 of the IEC 61131-3 languages, very popular products like the SLC 500 and Micrologix only supported ladder logic. And so this was great for a lot of people. Of course, they also came out with the Compact Logix shortly thereafter the ControlLogix, so a lower cost version of the same controller. The I/O cards were great because no more did they have dip switches or jumpers on them. All the settings for the I/O cards were stored inside the controller itself, which was cool. And of course, the programming software also had native tag support. So you got rid of N70 and T40 and C50, and now you could create any tag with any name you want. Well, as long as it was within the limit of the tag name, didn't start with a number. But in any case, you were free to design. If you wanted to call your timer My System Timer 1, you could. And it supported arrays as well, which were important because you may want 20 timers in one array. It was also cool that when you added the I/O, whether it was local or remote, you automatically got your I/O tags, which was very cool, right? So no more of the PLC 5 situation where you had to do block transfer reads or writes. No more of the DeviceNet where I had to go in with some separate software and map everything, right? And even ControlNet we used to have to map on the PLC 5, but with ControlLogix, all I have to do in RS Networks for ControlNet is schedule the network. Everything else is done right inside RS Logix 5000 or Studio 5000, depending on which generation of controllers you're using. And so that was very cool too. So really definitely a giant leap forward. Now from there, I want to stop and take a look at today, what people are calling PLCs versus PACs. So I've read a lot of articles. I've actually done videos on this, and a lot of people are claiming that PACs are all next gen and PLCs are all old style things that don't do the new applications very well, that they don't have all this and that and the other thing. And, depending on whose article you read, they'll say they can't do this or that. But I want to challenge that here in this section of the podcast And I'm going to do so. I want to compare today's number one programmable automation controller, PAC, in North America to the number one programmable controller sold in the world today, the S7 PLC from Siemens. So let's take a look at the Allen Bradley PAC, right? Number one PAC in the USA, in the North America market. Now, the control logics and compact logics, you'll find 99% of them are programmed in an IEC 61131-3 language, right? Ladder logic, function block, structured text, sequential function chart, right? Now, yeah, Rockwell does have their own language, like a phase manager, which is like PACML, right? But you're going to find most of the programs out there are going to be on one of those IEC 61131-3 Programmable Controller standard languages. Again, we're talking about a PAC here, right? But it's it uses standard Programmable Controller languages. The other thing it supports is add-on instructions, which is very cool. You can use one of those standard languages to create your own block, and then use that block in any language anywhere in your program. It's also tag-based. We just talked about that. And it does support the ability to create your own data types, right? So if you're creating something that needs a float, an integer, and a few bits, you can just create your own data type right in the software. The controllers all support multitasking back to the very first control logics. That means you can have a continuous task, you can have a bunch of periodic tasks, you can have a bunch of event tasks, all running at the same time. So multitasking. And all the controllers today from Rockwell are multi-core. So you remember back in the day, we first got our dual-core Intels, and then we got our quad-core Intels, and only the good Lord knows how many cores there are in the current generation of CPUs. But PACs went the same way, at least in Rockwell's world. They now sell all multi-core controllers. And they also offer controllers that are rated for safety, and they also sell controllers that can do advanced motion control, right? And that is North America's number one PAC, okay, by several factors. Now let's compare that to the world's most popular, most sold, most used PLC, the S7, like the S7 1500 or 1200. So first of all, most of the programs you'll find in S7 1500s and 1200s use one of the IEC 61131-3 languages. Yes, Siemens recently released their cause and effects matrix, but 99% of the programs you find out there in one of these S7s, it's going to be in either ladder, function block, structured text, sequential function chart, or instruction list. And I know some of the languages have different names in Siemens, but I'll just keep with the Rockwell names for now, so we can compare and contrast. And you know what? Siemens PLCs, they support add-on blocks or add-on instructions. You can design a complete program as a function block and then reuse that in your programs elsewhere with unique instances, right? They're tag-based, right? And they also support user-defined data types. Nothing fancy about that. They support multitasking. You can have a continuous task. You can have periodic tasks. You can have event-based tasks, right? They may have different names in Siemens, organization block, right? Function block, function. But in any case, you still can have continuous, periodic, and event-based. They support the newest releases from Siemens are multi-core CPUs, and they do sell fail-safe or safety CPUs as well as CPUs with advanced motion control capabilities. So what I just said about the Siemens PLC, it sounds identical to the Rockwell PAC, doesn't it? And that's because they're both programmable controllers. Just because one's a Chevy and one's a Toyota, they're both, those are both car names, right? Names of automobiles. And it's the same with the Siemens and the Rockwell. They're both programmable controllers. They both follow the IEC 61131-3 standard. Yes, they each have very unique features. Yes, the development environments are very different. It took me a while to learn Siemens a few years ago when I started using it. But in any case, they do the same things. They're both programmable controllers. So for those people out there who say, a PAC is going to program in C and have 10 times the memory and is really never used for clickety-clack applications, I have to disagree with them. PLCs and PACs today are really both programmable controllers. Now, I will admit that companies like Rockwell and Schneider, they like to call their newer products PACs to differentiate from their legacy products, PLCs. I mean, they were some of the first PLCs on the planet, right? But in any case, if we take a look at the S7 line from Rockwell or PLC Next from Phoenix Contact, their PLCs are on par with any PAC on the market. So I wanted to address that. Now, let's turn here and take a look at what the major vendors are doing today. Now, I've had the luxury of interviewing a lot of these vendors, and I want to kind of summarize what I found from them. And with Rockwell, we've had them on the show many times. And I really see that, for my personal opinion, I think their focus is on capacity, speed, and higher functionality. Okay, so if we look at capacity, it seems like every generation of Rockwell controllers come out with the support for more I/O, more Ethernet drops, and larger programs. And so that's what I mean about capacity, right? And then when we talk about speed, it seems like every generation, the controller gets faster, its scan time gets faster, either 2 times, 4 times, 10 times faster. And then the networking gets faster. Currently, we have gigabit Ethernet I/O that can talk to a gigabit Ethernet network cards in a ControlLogix chassis or in a compact Logix, right? So that is huge. And it's not just that the network's faster. I mean, our response times on these I/O modules have gone down from milliseconds to microseconds. So overall, the systems are completely, many levels faster than what we had 10, 15, 20 years ago. The other thing, the higher function things, you can see like with their new P controllers, they just added this huge new instruction set based on process applications to these new P controllers. So they do everything the old controllers did, but now they also support all this new functionality, which I think is huge. And it's just built in the firmware. You don't have to download any plant packs, this or that. It's just all built right into the controller. So, and as I say this, as I go through what I think Logix is doing, I kind of, reckon back to that PDQ2. I mean, what was the big things about the PDQ2? It had to do higher level functions and it had to be high speed, right? And it's almost like that stayed with Rockwell over the years. As a matter of fact, one thing that did stay is that XIC and OTE, that was originally, those mnemonics that were originally in the PDQ2, they're still in the controller today. Most PLCs would call them, or programmable controllers would call those instructions, a coil and a contact, right? But in Rockwell terminology, that's an OTE and an XIC. So in any case, if we take a look at Siemens, to me, it seems like their focus is on features, right? So if you've never used an S7-1500 with that gorgeous display in the front, you got to try it out. It's like, it harkens me back to when drives first got their HMIs. You could actually see all the parameters in English and not have to look it up in a book. What's parameter 58 do? Well, that's what this does for the PLC. I mean, you can check the MAC address, the IP address. You can set the IP address. And it's not some little, poorly lit LCD. This is a full-blown color display that can show you alarms and errors and just all kinds of stuff. The model, the firmware, and all of that, right? And even do things with the memory card and whatnot. So very, very cool there. And then, of course, in many of their controls, almost I think all their CPUs today can be an OPC server. So you don't have to go buy an expensive suite of software to get OPC connectivity. The PLC itself can be an OPC server, which I think is really cool. Another thing they do too is they allow you to not just read and write tags over Profinet, their version of Ethernet field bus, but you can actually read and write tags to other devices on other Ethernet protocols. For instance, I recently did a video where inside my S7, without an expensive gateway or any expensive software, I was able to read and write tags from a ControlLogix over Ethernet IP from an off-the-shelf S7. I thought that was really cool. And one of the things they're doing there is they're supporting multi-field bus in their I/O systems and other products, right? So you can buy an interface module today that will support Profinet, Ethernet IP, and Modbus TCP all at the same time. And I think that's so cool. I see other companies doing that too out there, and I think that's a great trend in the industry. And then let's look at and talk about view of things, right? It's like an HMI light built into your PLC. Now, I know there have been PLCs on the market from these other vendors who are PLC and HMI, right? Full blown, right? And we even looked at one here that's based on CodeSys. It's the IFM HMI controller. But for Siemens to add this into their existing product, a lot of products have custom web pages you can put in them. But this is really, you're using like a comfort panel type objects on these screens that you would normally build for a comfort panel. You're putting these objects, and again, there is a subset. It's not every object. But you can put these objects on these screens. You can download it to the SM1500, and you can have dashboards or some simple HMI screens living and breathing and being updated by your SM1500, which I think is very cool. And of course, we have the brand new cause and effect matrix language, which we covered on the show. So for me, when I look at Siemens, I'm seeing features, like a big focus there on features. Now, when we look at Schneider Electric, a lot of what I've seen, now this is a company that still makes Modicon PLCs, right? A lot of what I see what they're doing with their new DPACs, the distributed programmable automation controllers, is this whole adoption of IEC 61499, right? And supporting the universalautomation.org folks, right? So this is a place where you have your software is separated from your hardware, right? And so if I have some software that can program something that meets the specification, I can use anybody's pack, right? So in this case, and really to take it to the next level, I can actually develop an application, let's say an automation expert, and then deploy it to multiple devices, right? So one application deployed across multiple pieces of hardware. Maybe it's a couple of D-packs, maybe it's a VFD and some sensors. One application downloaded across multiple devices, which I just think is mind-blowing. So if you're interested in that, you can, of course, check out our interview with them, or go look up 61499 or check out universalautomation.org. And the final vendor I want to talk about in this section is Phoenix Contact with their PLC Next product. Now, they call it a PLC, but it has some features that a lot of PLCs don't have, even PACs don't have, right? So let's take a look at this. First of all, it is a PLC, right? It supports IEC 61131-3 languages. You know, it's what you expect from a PLC. There's I/O modules, there's programs. But one of the differences with their PLC is it also natively supports HTML5 and C++, right? It's a PLC that natively supports C++. Very interesting, right? The other thing is, because it's based on an open Linux platform, there's another part of that controller which can support any kind of code you want to write, and maybe in Java or Python or something else. And because part of their controller is open, right, for those type of applications, they actually standard on the IEC 62443 security model to make sure that your controller would be secure and safe. So very interesting stuff by all of these vendors. I'd love to get more vendors on to talk about what they're doing. But as far as our existing shows and articles and podcasts, you'll find all of those up at theautomationblog.com. And for the sake of time, I'm going to go ahead and end the show here. I hope you enjoyed it. If you did, please give us a like and a sub. And if you'd like to follow me or get in touch, you can do so over at automation.locals.com. And as always, you'll find all of my training courses on PLCs, HMIs, and SCADA products over at theautomationschool.com. With that said, I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.